Ay,
Dito po kami.
yes.
Nakaupo kami.
Tatayo lang. Mas maganda pag nakatayo. Anong shucks? Okay yun.
Tayo naman yung search. Parang sa akin.
Started tayo from 3. Tingnan ako sa labas, baka tago sila sa labas. Hey, for AWS Meetup ka.
Si ano ba?
Biglang pa sa pera. Dalawang ano na pala ito.
Pwede nga natin i-project yung laptop. Kailangan yung install agent to.
Para kita pati.
Parang yung presentation.
Ito yung pa-amot na siya sa F-Stream.
Kaya huwag ka maniwala doon.
Hindi dapat dito na lang kayo bro. Para mukhang kasi nakikita lang yung upuan. Pati kayo try nga. Punta kayo dito para makita natin kung saan tatayo dapat.
Broadcast na ba yan?
Na-forecast ito, diba? Up na yun. Hindi na ba?
May online na.
Dito pa, Lors. Lapit ka pa rin naman. Lapit ka pa ng suwal. Yan. 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 Okay. That's very good. Kaya kung may stable internet.
As live stream.
Sa isang collab natin meron. Sa just may kami to. Okay. Pero actually si nakilala na si John.
Isa kami.
Oh, si John is our talaga. So SEP na service engineering.
Ito.
Pero on the side is our live stream Yun ang kanyang side business. Pwede rin sa lamay. Online, online lamay.
St. Peter.
St. Peter meron pa rin. Pero doon natin sa taas lang yun.
Live streaming. Dali naman. Ngayon ako sa akin ng Meetup na meron.
Boss, pwede pa natin i-arrange.
May kulang pala.
Different
Different cameras.
Play na.
Portable ba?
Tangkal.
Dali ko.
Ayan. Guys, we'll start in 3 minutes. Like that. Yung traffic na yung mga tao. Sa kapag Josh sa BGC.
BGC.
Ilang hours yun?
Siguro mga 1 hour and 15 minutes. Si Dennis ba?
Just Dennis is
Ngayon na si Pedro.
Okay.
First time.
Kasi,
Sumasama ba siya? Set ba yung event? Ortigas mo na. Paano yung meron kami kasi yung iba natin yung isa kasi dito sa sa inyo din sa hindi na priority. Hindi mo siya ito. I see this.
guys. Want to start na yung mga friends natin, darating mamaya pa. Good show. Yeah. Alright, so good evening and welcome to the first AWS Meetup of the year. So my name is Diwa Del Mundo. So I'm the guy who sometimes posts the Meetup page, and this is actually our, I guess, third year na of having meetups. I work for Voyager Innovations, that's why nakachakit ako ng Voyager. And this is actually Voyager's third straight year of hosting the AWS Meetup. So I'm proud to say naman that our company is supporting the group. And actually, I'm also proud that my colleagues in Voyager are sharing their knowledge into the community by giving a talk about AWS, Simple Workflow Services in Node.js. So yeah, so sounds great. But, so last year, 2015, to give you a short background of what happened, we have around 10 meetups, okay, for the entire year. So, and for the first time last year, we had a meetup outside of Manila. So a lot of people from the provinces are saying, how come puro Manila lang yung meetups? So we tried to have actually we had a meetup in Cebu last year. So it was the Dubai co-working space. So we were able to have the AWS orientation day, and of course have the meetup afterwards. So I think it's a good experience. And yeah, I'm also glad that I see the regulars last year nag-attend and nagsusupport sa group, and hanggang ngayon nagsusupport pa rin. Pero of course, I'm also happy that we have new faces. So if this is your first time to attend the AWS User Group Philippines Meetup, so welcome to the community. I'm glad to see you here, and I hope you learn and support the community. Yeah. Okay, so we're going directly into the first talk. It's workflow management with AWS SWF in Node.js. So we have Lorraine, Lachica, and Erica Padilla of Voyager Innovations. Right.
Hi everyone, good evening. Thank you for joining us today. I'm Lorraine and
Hi, I'm
Erica. So first, we're part of the payment gateway development team, and one of the projects that we're involved in is the Checkout API. So what does the Checkout API do? So merchants are onboarded on our system, and they make use of our secure payment page, wherein they can perform and process credit card payment transactions. So one of the use cases or one of the requirements is that for us or the Checkout API to send checkout details through webhooks. So what are webhooks? So the merchants will give us a URL where we can post checkout details after we've successfully processed the payment. So under the covers, here's what the architecture looks like. So we have the Checkout API. Okay. After the processing of payment, the checkout information or the checkout details will be pushed to a message queue. We're making use of AWS SQS. And we have a webhook worker. And what it does is that it's scheduled to pick up those messages from SQS. And then through the URL provided by the merchant, we post those checkout details to the merchant backend. Okay, this setup works for us. It's good and it gets the job done. But a requirement came in. Okay, we're tasked to send an email confirmation to the buyer and also a copy of that payment receipt to the merchant. So if we're going to implement that, we have to create a dedicated queue that will hold all the messages relating to the sending of email. Okay, and we have to add another worker that is dedicated for sending those emails. Okay, the sending of email and the sending of webhook, they can happen in parallel. So what the Checkout API must be able to do is that it should keep track or it should know whether those jobs were done successfully. Okay? The problem with this kind of setup is the coordination, because it's difficult to keep track since the two jobs are very asynchronous. Okay. Like us, developers today has the emerging need to develop applications that rely on asynchronous interactions and loosely coupled design. Okay. Those applications will also run across data centers and the cloud. So some of your components might be in your private data center, and some of it can be on a cloud. Okay. Also, elastic scaling is not enough. Okay. We have to scale selectively for us to be able to be efficient in terms of resource usage. Okay. The challenges with this is that it's difficult to do with the existing solutions. Aside from that, developers might need to write complicated infrastructures that might consist of a message queue or a database. Aside from that, we should also develop a complex logic to synchronize everything. I have here some of the companies that face these similar problems. So Golf Tech is a leader in golf instructions. So the problem they're facing is that they find it difficult to scale because they have a traditional data center setup. Okay, because of that, they have accumulated over 48 hours of video backlog. And another problem is that they were not able to keep track if video has not been processed successfully unless a customer comes in and report that he didn't receive the tutorial video. So that is not a very good user experience. And the next company is Lyft. Lyft offers a carpooling service. It's a competitor of Uber. Okay. It has a partner enrollment that composes of multiple steps. And those steps can fail anytime. And Lyft should be able to send reminders through email or SMS to remind the user to move their application forward. Okay. What are the similarities? What are the similarities of our problem and with the problem that Contact and Lyft is encountering? So the use cases compose of multiple steps. It should run on multiple machines, and that would mean higher potential for failure, and of course, it needs resiliency, scalability, and even auditability. That's where AWS, SWF, or Amazon Simple Workflow Service comes in. It makes it easy to develop applications that coordinate work across distributed components. It provides non-duplicated at most one task delivery. It provides consistent state management. So if you're managing state machine on your application, you can offload that and let the SWF manage it. It individually tracks execution and tasks since the task queues and routing is built in with SWF. SWF is also able to manage timeouts and even execution statuses. SWF is also good for long-running processes. So if you have a process that takes a year to finish, it will still be able to know what is the state of that particular process. Now, what are the benefits that we can gain from SWF? So you can build applications with components that run anywhere, anytime, and even intermittently. Okay. For us developers, it lets us focus on application logic. So we don't need to think about a very complex, or we don't need to implement our own workflow platform. Okay. Aside from that, it makes application to take us to market it faster, and it minimizes administration and even infrastructure costs since we don't need to invest on orchestration infrastructures. And lastly, and most important of all, it's we can benefit from its scalability and flexibility. So if you remember, this is our architecture before. We're using SQS. Then we organized it. Then we use SWF. Now, we have a decider. The decider is in charge of the coordination. So we were now able to know what task has failed, and if it failed, we can retry it easily. Also, we have an activity worker, and it can do either of those three jobs. Okay. If ever there's another new requirement, we can just register it as a new activity and include it in the workflow. So for us, it is now more flexible. We can support other requirements, and it's easy for us to manage since we can view or we can drill down the history of executions in the Amazon console. Okay. For GovTech, they benefited from SWF when they moved their traditional data center up to the cloud. They were able to process over 30,000 videos per day, and they were able to retry failed video processing. And left, the state of the user's application is consistent. The reminder emails were never duplicated, and even if it takes for a user to complete, it takes too long for a user to complete his or her application, the current state of that user's application is still there, and Lyft can easily know the current progress of that user. There are lots and lots of use cases for SWF. You can use it for analytics, report generation, and even batch processing, and a lot more. Now, I'll turn you over to Erica to discuss about SWF integration in Node.js.
So let's get down to the nitty-gritty details part. I won't dive deep into the implementation details, but I'll walk you through how you can design your application components to interact with SWF. Okay, so first things first, you need to register for an Amazon account and then generate access keys via the IAM console. So you will be needing those keys to sign your programmatic requests that you make to AWS. There are a number of ways to integrate with SWF. You can actually perform SWF operations by doing direct HTTP calls to their servers. Fortunately, in Node.js, there's an available SDK that we can use. However, the downside is that the SDK is just a plain wrapper to the API itself. There's no available flow framework unlike in Java and Ruby. The flow framework is an enhanced SDK that has this pre-built workflow-related objects and classes that really makes integration with SWF easier. But then again, we could still do away with Node.js. There are a number of Node modules that are built on top of the core SDK that we can use for development. Okay, so we keep on talking about workflows, but what exactly is a workflow? So a workflow is a sequence of tasks that has an objective. So let me just dissect the statement into to highlight important parts. So it's a sequence, it follows a certain order, and it's a set of activities. So it consists of multiple tasks. Suppose we're asked to create a flight booking system. Modeling it in a workflow system would more or less give us this diagram. So after the selection of flight, the backend would verify the flight details. It would check for available seats and stuff. And then if everything goes well, it would process the payment by charging the credit card. And then if successful, it would email the booking confirmation to the customer. And thus the end of the workflow. So here's an overview of the different SWF actors in play. So at the center represents Amazon SWF. So as you can see from the interconnection, it acts like a coordination hub of the different components. And the three components that you will be implementing are the workflow starter, decider, and activity workers. So their roles is pretty much straightforward. Their names imply what they do. So the workflow starter starts the workflow execution. It triggers SWF to create a new workflow. The decider, on the other hand, decides how the workflow should proceed. So it's the one that issues the scheduling of tasks. It also issues the stopping of the workflow or the completion of the workflow. It acts like the brain of the workflow. In more technical terms, it holds the control logic of the workflow. Activity workers are more straightforward. They do the actual job. So, relating it to the description of workflow, the sequence is handled by the decider, while the actual processing of tasks is done by the activity workers. I put here the management console. It has a direct access to SWF. So it provides an interface where you could actually view the status of the workflow executions. Okay, workflow setup. Before you can use any activity types or workflow types, you must register them first. So domain is a logical container. It's an AWS resource for specifying workflow scope. So each workflow belongs and runs within a single domain only. So you have to register the domain. You could specify any name that you think is appropriate. Then register the workflow type. So for our particular example, it would be the flight booking workflow. You would register it as such. And then for the activity types, you should be able to identify the component tasks of the workflow. So for our case, it's these three boxes: the verify flight details, process payment, and email booking confirmation. So this would be your activities, the decider. So we move on to implementing our decider. As I've mentioned earlier, it controls the workflow logic. So basically what happens is that the decider calls for a decision task. Decision task is actually is issued, it's created when the status of the workflow changes. So for example, if there's a new workflow execution, there's a new decision task. Or if an activity completes or a timeout occurs, a decision task would also be issued. So what the decider does is it interprets this decision task. It filters the workflow execution history given to it and then decides what to do next. So it could issue any decision such as scheduling a new task or completing a workflow or starting a timer. Basically, the decider is really the brain of the workflow. Activity worker, same flow as the decider, but then except that instead of getting the decision task, it gets an activity task. So it calls for an activity task, and then it takes in an input, it performs the job, and then it reports the result back to SWF. So what it could respond to is if the activity failed or if the activity has completed. Okay, so for both workers, the activity worker and decider communicate with SWF via the long polling strategy. So it's actually a balance between the traditional polling strategy and the push technology. So what happens is that when the activity worker and decider instantiate or initiate a request to SWF, SWF holds the TCP connection open for a minute. And then if an available task is ready, it would push it to the worker right away. However, if no activity or no task is available within that period, it returns an empty response and then the workers re-poll again. Workflow starter, so it's any application actually that initiates workflow execution. It would use the start workflow execution operation to trigger SWF to create a new workflow. So for our flight booking confirmation example, it can be the page wherein the user selects the flight. Okay, so let's simulate the data flow in a flight booking workflow. Take note that the decider and the different activity workers are already polling for decision tasks and activity tasks. So, upon customer selection of flight, the application would trigger SWF to create a new workflow. This would then ask SWF to create, to issue a new decision task. So when the decider polls for a decision task, it would receive that a new workflow is created. So it responds back to SWF that, hey, you should schedule for a verify flight details activity. Now, SWF creates an activity task for verify flight details. And then when verified flight details calls for the activity, it receives it, so it executes the task, and then it reports it back to SWF. So the decider, upon receiving that verified flight details has already completed, it would now schedule for the process payment activity task. Same exchange goes on until the workflow is finished. Now, when the email booking confirmation is already scheduled and has completed, the decider now completes the workflow. So you could view all the workflow and data flow exchanges in the AWS management console. There. So you could actually monitor the workflow executions by the visibility APIs exposed by Amazon, or you could directly interface with it through the management console. Okay, so here's a demo application we created. So it's a So it's
Is this a video? Oh, okay. Yeah, I need to turn up this. There it goes.
I-zoom mo na lang yung screen mo. Balik mo.
Right. Yeah.
Yes.
Can you guys see?
Can you guys see it?
Okay, so this is a console-based demo application that illustrates how the different SWF actors interact with one another, you could actually visit this link to run through the demo.
So we're going to post the link to the slide and even the demo link later to the Facebook.
Yes. So okay, in this part, we're running the registration script. So we've registered for the domain, the workflow, and activity types. And then in this part, we would be running the decider, the verify flight details activity worker, process payment activity worker, and the email booking confirmation worker.
Right. So it says decider.
Yeah. I think that's
Okay, it's good. Okay,
there. Then we would trigger SWF to start a new workflow. Okay, upon trigger, the decider receives it, and then it schedules verify flight details activity. Then the verify flight details activity receives the new task, executes it, and then upon completion, the decider receives it again, and then it schedules the process payment activity now. So it receives it. Processing. There. Again, the decider receives the result of the processing payment activity, schedules the last activity. So there, the workflow has already completed. Okay, now I'm giving you back to Lorraine to discuss the difference between SQS and SWF.
So earlier during my discussion, so I've mentioned SQS. So here's a very quick comparison between SQS and SWF so that you would know when to use SQS or SWF. So for SQS, it's message oriented, unlike SWF, it's task oriented. Okay? In SQS, there's a possibility that you'll be receiving the message more than once. And in SWF, it guarantees no duplicates. For SWF, it has a built-in tracking and auditing. In SQS, you have to implement it your own. Okay. Here are some useful links for the SWF documentation and including the demo application. And that concludes our discussion. So if you have questions,
Can email us.
A round of applause. Alright, so let's have 5 to 10 minutes for questions. Feel free to ask our very talented engineers from Voyager. Hi guys, meron ba? Gusto nyo, do you want to ask them? Maybe i-quiz natin sila. Tingnan natin kung retain natin.
okay, you
My question, did you ever hit parang higher threshold kung kaya i-process ng workflow? Say, 1 million tasks ba kaya mo i-handle? Or would it auto-scale to handle that volume of traffic?
Bro, okay lang kayo para ating live viewers can hear you. Nasa tayo mic. Yeah.
Yeah, okay. So my question was...
Lapit ka rito. Nasa ba yung mic bro? Dito.
Ay, dito.
Dito.
Okay ba blocking? So my question was, did you hit the upper threshold of the performance probably of the workflow? Would you say that it could easily handle a huge volume, let's say 1 million users, sabay-sabay yung task? Or it wasn't part of the scope?
In AWS, there's actually a limit of just 100 1,000 open executions. And if you want a higher limit, you have to contact the Amazon, but it allows for that. And as for
regarding about the scalability issue or the auto scaling, so you have the designer and the activity workers. So in the event that there are too many jobs that need to be processed, those activity workers can auto scale. They can span multiple instances, and also the designer. So our setup currently, it is in an auto scaling group. So we don't have any problems in case there are multiple transactions happen concurrently.
it would just add another activity worker to handle this one.
So for for each of the working pieces, it would scale. Let's say it needs more decider. It would scale the decider only, and not the
Yes.
whole.
Yes, yes. you
That's
can-
the benefit from using SWF.
Okay, nice. Any more questions? Ed.
May I know if the decider uses what kind of notation? Does it use BPMN or other kind of notation for the flowchart diagram?
Oh, sorry, what do you mean by notation?
Um,
Like, how do you describe the workflow? Is that what you're asking?
yes, sir. Because usually for business process management, it uses BPMN.
Okay, okay.
So,
So it's like a domain-specific language.
so that's just one example. I want to know if what kind of notation does SWF use?
There's no particular notation for SWF in terms of handling and representing the workflow. What happens with the decider is that it receives a decision task, and then it would get the history of the workflow. So from there, it would interpret where is the workflow currently on, and then it would issue a decision where the workflow would go next.
Actually, you are the one who will design the workflow, because you will dictate what the designer should do if ever he got or the designer got this particular kind of task or decision task.
Just a follow-up question. How would the developer or the user design the workflow itself?
Just like we mentioned, you should identify the component tasks in a system. So for our particular example, there's a payment processing part, there's a verification part. So you must be able to identify what are the steps.
So it is not like a very configurable type of service wherein a person just modify the workflow in order to update
Adjust.
yeah, depending on the requirements of the business flow.
There are sample workflows that you can go by, but you will be the one implementing the actual processing for the workflow and how it moves. The SWF just works as a centralized orchestration that delegates tasks to different components.
Alright. Anything else? Okay, so I guess that's it for our workflow management with AWS. SWF in Node.js. So again, let's give a round of applause to our. Great, so thank you, girls. Okay, so it's one of the most important parts of the meetup. It's the snack time. So let's spot and dine on this area. And yeah, so the food is here. So let's follow my
Sorry.
Hey, how are you? How are you? You come from Padilla?
Yes.
Yeah. On the traffic, market. No, by the time we left here, it would be last time you go anywhere, you always stay in a hotel. Yeah, I brought some colleagues from getting the rest of them. I'm working on. I am introduced in some hello. We meet again.
Asa ano kaya? Home base.
I wonder next time. I wonder next time. Iwa, saan pa tayo next time?
Wala pa. May suggestion mo ba? Okay na. Ano mo na? You want to get it? Here, apply.
Here, you can have this. I will volunteer was.
I just got this month because last year we went to Las Vegas. Right? I left my seat with this jacket to reserve my seat. When I got back, my seat is gone together with the jacket. I just got this. Like, for some reason, it went back after several months. So I just got this one.
So I should tell HR to give me another one. That gave me an idea. Because you live in here. Yes.
I brought this to Las Vegas. This is the one I'm using when we're traveling.
So you have a new one.
That is the same. I think someone took it. I don't know. Maybe he got guilty. Put it back.
So how did it go?
I don't know. Ask English. I mean, there's a missing small jacket. So that's fine.
I will tell HR that I know someone. Maybe they will give me another.
Yeah. Pasok ka dito. Wala. Sa'yo, para meron kang reserve.
Yung nakakita ko yung credits.
Meron silang utilizing AWS
Yung mga ganun bagong hindi sila makapag-concentrate sa business nila.
Ganda yan. Thank you. Nakamak na yun.
Kaya siya bro, mga 20 to 25 minutes. Ang gawin natin, so first the Q&A for you. Tapos parang open discussion. So some friends, of course na, syempre yung mga essays should help with answering. Lalo naman na para sa session. Yeah, hindi ko. Pasok ko lang yung front page. Mga experience. Isa na next time.
Try ko na siya sa...
Meron pala siya. May pakita sa recover pa. Invite mo siya sa party ko ng January. Hindi siya nag-asal. Pero sabi niya yes. Siya yes. Hindi yung pakita.
Hindi ko na sinabi. Kaya nung kasi siya, sabi ko, sabi tingnan mo dyan. Sige. Parang ka na na-promise na ulit.
Yung mga kasi, nakita mo mo kasi. Nahanap ko siya. Nakita na sa tuloy mo.
Sige. Oo nga, no?
Hindi ka makita na, sir.
Oo nga eh.
Tapos yung ano yata bro. Kailan mo internet? Kailan mo internet? Yeah. Da, ano yata? Dito yata. I'll tell you lang.
Sige, alam ko ba nandito yung safe?
Okay na, test natin.
Alam ko dito siya.
Gonna see you. Guys, let's start. Readable. Probably kasi may key.
Parang dito.
Pero ano naman dito?
Kasi parang dito eh.
Pinagyan na tayo para skin.
Oo nga, parang moreno tayo.
Moreno tayo.
Sir, you have to stay this side.
Yeah. Guys, muna tayo. Start na tayo. All right, guys. Okay. Thank you. I hope you had a wonderful dinner. It's sponsored by Ambers, and now we're going to have a talk about AWS OpsWorks and CloudFormation combo. So one of our co-organizers in the AWS Meetup, AWS User Group Philippines, is Joshua Lat from Grocer. Okay, so Josh, take the lead.
Alright, so thanks D1. So, alright, so tonight I'll be presenting both OpsWorks and CloudFormation and how they will work together to automate your entire application infrastructure. So most of the time, people try to compare which one is better. Sometimes people think that one cannot be used without the other. So this presentation will help enlighten you on how to use both and making the most out of the strengths out of each tool. Alright, so I've been working at the Grocer for about almost 4 years, so 3 to 4 years. And I started there as a web developer. we didn't have a system administrator. So we're the same people who make sure that the site is up. So what happens, what has happened before is that we were the ones building the websites, and we were also the ones maintaining the infrastructure. So what happens there usually is that when the site is down, you have to wake up at 11 p.m. or 12 midnight, sometimes 3 a.m. And we had to bring that up again because every second that the site is down, people will be able to buy from our site. So in terms of resource allocation, it has always been our problem. Who is gonna do this, who's gonna do that, and somebody needs to manage the infrastructure. So after 2 years, we finally learned and we realized that we had to do this. So what we did is maybe we can automate some things and maybe we can do some things better. So what we did is we tried to automate things. So anyone here familiar with CloudFormation or OpsWorks or Chef or Ansible, Puppet? Ansible, right? So anyone familiar with other automation tools? Like, for example, who here uses Rails? Max use Rails before? Or other frameworks like Django, PHP frameworks, etc. Alright, great. So at some point, you'll realize that when you have been deploying a lot of web applications, for example, some of those stuff is repetitive. So what you can do to speed things up is to automate these things. So I realized that there was really a need for automation. So last year, one of our efforts to speed things up is to automate the deployment and provisioning of the servers. So right now, this is the symbol, this is the icon for CloudFormation template. And this one is for OpsWorks, and this one is for the virtual private cloud environment, and then this one is for Lambda. Who here is familiar with AWS Lambda? Serverless computing. Alright, so I'll tackle this also. And then what this slide shows is that what we did is we standardized this part and we automated this part so that every time we decide to launch a new product, the deployment and the setup of the staging and production environments can be done in 40 to 50 minutes. So before, it took us 3 days to prepare the instance, just one instance, because you have to install everything, have to be there, say, apt-get install like this, update, etc. But with the automation tools, we were able to code the automation scripts using, for example, here, Chef with OpsWorks. And you have also documented and automated the network side. So that's the strength of CloudFormation for the network side. And then we use OpsWorks and Chef for the application side. So here's what happened. Before, this part was only experimental last year. It was only for one project. We decided to, hey, let's spend some time researching on Chef and OpsWorks, and let's try setting up the staging environment with OpsWorks and Chef 12. What happened there is that one of our projects had to be updated. So here, we had to, every time you have to change versions, for example, in Ruby. Before we were using Ruby 2.1, then suddenly something updated the other code base, they had to use 2.2. So the ones you have prepared before, which is in 2.1, had to be updated, and you have done that manually before. What we did is, hey, we have some automation tools and scripts here. So and since it's the same Rails stack, what we did is we just changed the version to 2.2, and then we just use OpsWorks to prepare to fix the old project. And that's where we realized, hey, maybe you can just use OpsWorks for the application side of all of our projects. Since in Grocer, most of our projects are in Rails, and I think that's around 80 to 90%. And since this set of scripts deploy Rails, so all of our projects can be deployed in the Lachica bottom. And OpsWorks, if it's the first time you've heard about OpsWorks, it's like an AWS wrapper for Chef. So if you know how to use RDS, and RDS is like AWS wrapper for Postgres or MySQL, OpsWorks is like a wrapper for Chef. So gives you an interface, and it makes it easier for you to automate a lot of things. All right. So let's start first with AWS CloudFormation. So AWS CloudFormation is AWS own tool to automate the creation and deletion of the AWS resources. So this is something that only AWS has, in the sense that this is tightly integrated with AWS. So here you have CloudFormation templates. So templates are just text files. So they're in JSON format. And there's a web interface in the Amazon console. And all you need to do is upload the text file there, and then it will generate the resources in just a click of a button. And the advantage here is that when you have, for example, you have to prepare a virtual private cloud environment, and you want to prepare the subnets, before, what you have to do is you have to prepare that manually using the Amazon console or via the CLI. So with a CloudFormation template, when you use that inside the CloudFormation console, if two subnets need to be created after setting up the initial VPC, and you want the OpsWorks layers and stacks to be created after that, you can write them inside the template. And the advantage to that is the entire infrastructure is automated. And then OpsWorks and the OpsWorks stack can be used to prepare the EC2 instances. And then of course you have RDS there. So everything in Amazon can be converted into text files. So except for the new ones, for example, there's in Amazon right now called NAT gateways. So anyone here using virtual private cloud on Amazon, all right. So in virtual private cloud, when you have a DMZ, you have a public and private subnet, and in order for the private subnet to work with the internet, you need to have a NAT instance. A NAT instance is just an EC2 instance, but it's a single point of failure. So Amazon has just provided a NAT gateway, which just makes sure that it doesn't go down. It's like a NAT instance, EC2 instance, which doesn't go down. So for these types of examples, where CloudFormation has not provided support for that yet, we make use of AWS Lambda. So Lambda just uses the AWS SDK to create the Lambda programmatically. So that's also possible. Alright, so after that, this is just a basic example of what CloudFormation can do. So anyone here familiar with this diagram? This is a standard diagram for a VPC, Virtual Private Cloud Network, with a private subnet and public subnet. So they're in two availability zones. So you have your databases here, and your web apps are probably here. And you have the elastic load balancer there. You can write and document and automate the entire setup of this one inside a CloudFormation template. So instead of hiring someone who will manually do this, why don't you just write a CloudFormation template and document the entire infrastructure and then run it. The advantage here is that if it takes a human to do this manually, it would take him or her probably, let's say, 2 hours. Let's say that. 2 hours to set this up. So use the console, click, etc. But if you document it with CloudFormation template, all you need to do is upload the template, run it inside CloudFormation, then try to grab some coffee, and after 2 minutes, the entire infrastructure has been prepared. And if you need to have 7 of this, all you need to do is run the script, run the template inside CloudFormation 7 times. So that's the advantage. Instead of doing things manually, the trick here is to automate. And you have standards also here. So, for example, you have 5 environments using the template, and you update the template to have additional security controls. All you need to do is update each environment, and instead of upgrading them one by one, all you need to do is just update it with a click of a button, and the additional security features inside the template will be applied to the corresponding environment. So that's one of the advantages of automation. you invest time automating things, and then the amount, it's like planting a seed. Then when the seed becomes a tree, the tree will give you shade for the rest of your life. So it's like that. Alright. Alright. So this is one example of the CloudFormation template. So this one has been simplified. So this has a lot of bad practice stuff inside. So ignore that for the meantime because we have to try to reduce it just to fit this script. But usually this is around 30 to 40 lines, and this part is separated into different files. So this is just a working CloudFormation example where some parts have been hard-coded, but for this one, this is usually a dynamic parameter. Alright, so this is an example of a CloudFormation template where it tries to prepare a Redis instance. So the type of the resource is an EC2 instance, and these are just the parameters. So if you need to prepare this template from your current AWS setup, so for example, you have an EC2 instance running and you have an RDS Postgres instance running, all you need to do is just check the description, and then you can just transfer the properties here. And there is also a CloudFormer tool which allows you to automate the creation of this part, and all you need to do is edit. So what's the advantage of having this text file? Having this text file will allow you to immediately understand your the setup of your infrastructure without actually debugging things inside. So this is critical because sometimes, for example, who is here familiar with the difference between the different types of the volumes? So sometimes you might accidentally launch something incorrectly in the sense that, for example, you forgot that this one is T2 micro, this one is small, etc. This one helps you document and automate the entire thing. And the amount of time to build this thing is really small, especially if you have been using this for a long time. And for example, for this one, if you have an entire CloudFormation template which prepares, for example, 9 instances, which has happened in our case, and we needed two staging environments. What we did, for example, in that project is we had a dump of the entire Grocer database inside an instance, and we also had to test something which is empty, so to help with QA. And since we wanted to have QA done after 2 hours, what we did is we launched 9 instances here in setup A, and then we launched 9 instances in setup B. And had Redis, Mongo, then Mongo Slave, etc. And the advantage there is that the staging environment is a copy of the production environment, and it makes it easier to test the special scenarios, especially the payment integration, etc. And so that's one of the advantages of the CloudFormation template, and it's just a text file. So no scripts, no anything. It's just a text file, a key value representation. So this one is in JSON. For example, it's just a key, something ID, and then this is the value. And with the CloudFormation template, it just has an input, has an output, and yeah, the input is inside the parameters, and you can just see the output inside another block. So that's pretty much how a CloudFormation template works. All right, moving on. So after a couple of months working with CloudFormation, here's what we have standardized in our projects. The advantage of standardizing the setup of your infrastructure and layering it in different parts is that you can add and remove resources based on need and based on the requirements of the application. So not only is the CloudFormation capable of providing the different environments, it also allows you to configure the environments based on the need. So here, we have created different CloudFormation templates, which requires the execution of the CloudFormation setup. For example, this one is in a separate CloudFormation template. This one can be in a different one, etc. So on and so forth. So for this one, we have also made use of AWS Lambda with Node.js in order to create the NAT gateway, which is not yet provided by CloudFormation. So right now, with CloudFormation and the Lambda-backed resources, you don't technically do anything. And the advantage here is that you can invoke a function inside CloudFormation. So this one is a template, and Lambda is like a regular program inside the function. So if you're limited by CloudFormation's abilities, you can make use of Lambda during the execution of that template, which is pretty cool because you don't pay for anything until that Lambda function runs, except for the storage. So in terms of cost, the storage and the execution, in terms of cost between storage and execution, compute cost much more. And finally, this talk is about making OpsWorks work with CloudFormation. So OpsWorks is in charge of application layer. So what if we didn't have OpsWorks? So with CloudFormation, you can technically create instances out of nowhere when you have an AMI. So the AMI is like the DNA of your instance. So for example, you have a working application and you want to clone that. You take the AMI, the Amazon machine image, and then you just launch an instance from the AMI. So same with CloudFormation, all you need to do is reference the AMI inside that template, and then when you run the template, an instance is launched with the given parameters. You can do that, and it usually takes around 2 to 3 minutes to launch that instance. But what if you want something which is more configurable? Usually web applications or other applications need to be configured, and it's not the same for each application. You want things to be more configurable in the application side. That's where we use OpsWorks. So OpsWorks is just a wrapper for Chef. So who here is familiar with Chef? Or yeah, like the earlier. This one is similar to having a framework where you follow the framework's rules and then you have scripts inside called recipes. So OpsWorks is just a wrapper for Chef. So for anyone who has heard OpsWorks for the first time, OpsWorks is just a wrapper for Chef, and it provides you an interface, and you can just run the scripts to create your instances, so on and so forth. So the diagram earlier is improved with OpsWorks. So earlier you didn't have the web instances there, and you can technically create anything inside. For example, you have an Ubuntu instance, the Ubuntu server here, and you want to install Redis, or you want to install Mongo, or you want to install Ruby, etc. You want to install Python, or you don't want to use Python 2.7, you want to have other things instead. You can use OpsWorks to help configure these parts. So like I said earlier at the start of this presentation, usually when you try to look for CloudFormation and OpsWorks, what the blogs usually tell you is that you have to choose one. But in fact, you can use both. So before, we were using CloudFormation alone to set up everything. We realized that it was hard to configure the properties of the web application. So what we did is we used OpsWorks and realized that what OpsWorks is lacking is the network aspect, the virtual private cloud, so everything else. So what we did is we combined both of them. And the advantage of OpsWorks is that it's inside Amazon Web Services. And when it's inside Amazon Web Services, AWS will definitely provide you with a way to write it inside the template. So what happened here? What happened here is that with OpsWorks being available to be written inside the template, it allows you to write OpsWorks properties inside the CloudFormation template. So now you see how things work out. So all you need to do is run the template inside CloudFormation, and the template has the OpsWorks properties. So it's like automating the automator. It's like automationception. So CloudFormation is like automating the creation of OpsWorks, and OpsWorks will help you automate the creation of these parts. That's why it's in layers, is that CloudFormation automates everything else. And what CloudFormation can't do is done by OpsWorks and AWS Lambda. And we're using this in 2 projects right now. So the advantage here is you can turn on and off your servers. So for example, staging servers are usually on, and sometimes nobody is using them. And the problem there is that you're paying for something which you aren't using. So for example, it's on for, let's say, 1 month, and you use the staging servers for 4 days a month. You have you have something which isn't being used, and you're paying for the other 90 to 95% or 98% of the time, and you're not using it. So what we do in our company, since we have a lot of AWS resources, and we want to reduce the AWS bill, is we turn it off. And sometimes it also protects you because something cannot be attacked if it doesn't exist. So what we do is we just delete the entire staging environment, and then all we need to do when we have a QA testing session, we just turn it on again. And that's pretty cool because you can do it inside the console. So everything is automatic and everything is documented. It takes some effort to prepare all of these things. But once you have done that, you can create a standard and then you can just run it and then apply it into different projects. So that's pretty cool. Alright, so this is just a summary of OpsWorks. So OpsWorks has a stack, a layer, an instance, and application. It just provides you with the different ways to group your entire infrastructure. So a stack is basically the entire application stack. And then the layer is just a way to group your entire setup into layers. For example, database layer, application layer. And your instance contains all your EC2 instances. You can have ECS, Docker inside, and you have RDS also. And then for the application layer, you can have configured custom variables for each of your applications. So OpsWorks is in charge of preparing your EC2 instances, ECS, etc. And then the advantage here is it also has an option to help you scale immediately. So a lot of things are automated there. For example, you need to auto-scale this. Instead of manually doing that in the EC2 console, you can do that in OpsWorks as well. And then it makes use of Chef. So anyone not familiar with Chef, this slide will help you clear out the concepts. So these are just jargon. So alright, so for cookbooks, this is just a collection of scripts. Recipes are just scripts. The development kit is just the downloadable kit to help to create the scripts. And then the Chef server is the server which allows you to manage the other servers. So that's technically that. And OpsWorks just wraps the entire script framework. Alright. So moving on. So this is, I actually got this slide from the Ruby Meetup last January, last month. So I also presented OpsWorks in Ruby Meetup also. So usually Ruby developers make use of this stack. So you have Nginx, you have Unicorn, you have Redis, you have Postgres, and you have Rails. So this is pretty much a standard stack. Some parts get replaced by Apache, etc. This one gets replaced by MySQL. This part gets replaced by something else. But this one is a good example in the sense that it has a database, it has a caching part, and this is for caching, and this is for queuing. But here, with Chef, you write recipes, you have custom attributes, you can put all your dynamic parts there, and you have the templates for the configuration files. And these parts are used to generate and prepare your instances. Alright? So any questions so far? So it has been clear so far that CloudFormation is in charge of everything else, and OpsWorks is in charge of the application side. So this is how the cookbooks look like. So the advantage of using a provisioning tool is that you can decouple the code for the application side and the code for the infrastructure side, the deployment side. So the deployment side has its own repository. That's where you put all the scripts, the recipes for Chef. So the cookbooks are just there to help you modularize your recipes. And recipes, like I said before, they are just scripts. So the application code is inside one repo, one or more repos. And the infrastructure side has one repo to help you automate the preparation and creation of the instance set. So right now, this is just a quick demo. So I won't use the EC2 console because I might have internet problems. So I just took a screenshot of each page in OpsWorks. So in OpsWorks, it usually starts with the creation of the stack, and all you need to do is just go to OpsWorks and just fill in the values inside. And then here's how the recipes look like. So anyone here who knows how to code in Ruby or knows any kind of programming language? Alright. So great. So if you're a Ruby developer, you know that this is just a block and you just put in the values there. And the advantage of being able to write things in Ruby is you can also use Ruby libraries inside. So this part is like a program written in Ruby to automate the creation of your infrastructure components. So for example, in this line, this one is really easy to understand. This one just tells you that you have a service called ready server, and what you want to do is you want to start it. So if you want to stop it, probably it will be service ready server action stop. So this part helps you automate and document the start and the stop of the ready server. And this one just allows you to prepare your configuration file from an existing template with the dynamic variables. So that's technically how Chef works. It's really easy to understand. All you need to do is just get the hang of it. And the advantage here is that you already know where the configuration file is. So anyone who has tried deploying the servers on their own and managing their servers, usually the hardest part is locating the location of the configuration file. So one of the advantages here is easy to debug, and then you need to update multiple instances with the same configuration file changes. All you need to do is modify this template or change the variables inside, and then just run the scripts all at the same time. So before, if you were to do that manually, you have to spend, for example, 1 hour updating each instance. Here, all you need to do is modify this lines of code, and then in OpsWorks, you just click deploy, and then you stir your cup of coffee, and then you're done. So that's the advantage of having OpsWorks. And then the last couple of parts are just screenshots. So this is how to just set up your OpsWorks environment. So all you need to do is type in the repository URL of your cookbook repository, and then you add your custom JSON here. So in OpsWorks, there are multiple ways to add custom parts. So here you have custom JSON, which allows you to put in the parameters of your environment. But there's also here, I'll show that later. So later you'll be able to see that each application, for example, if each website has its own set of environment variables. So you can also put your passwords there, etc. And you can make use of Chef and OpsWorks environment variable scripts to extract that from OpsWorks. So you don't need to put your environment variables and passwords inside your application repo. So you also don't put that inside your infrastructure repository, but you input that inside the interface. So it's like Heroku. This part is like Heroku. And then finally, you have instances. And the advantage here is that if you want to create 5 ready servers, all you need to do is click this plus instance 5 times. Then just say, okay, this is the size. So you have medium, small, etc. And then say, okay, start. So instead of spending, let's say, 2 hours preparing each of those Redis instances, all you need to do is click this 5 to 10 times, and then you're done. And the advantage here is that if you need to update all of them, you can just deploy, and then there's a checkbox, and then everything gets updated automatically. And that's pretty cool, especially if you don't have a lot of time, and you want to focus on something else. Alright. So this is just the stack of the Rails application. So for that, to customize this part, you have this only. And for example, in our scenario where the Ruby version is different, what we did is just change this 2.2, and whenever we update or create a new instance, it's in 2.2. There's no need to manually do that. So we have made this part dynamic. And for example, we had the app name is, for example, Voyager, for example. We just changed this to Voyager. And then there's a folder named Voyager inside the repo. So this part is the dynamic part. Alright. So this is the part where you can put in your dynamic parts for the application side. And then finally, this is like the combination of both OpsWorks and CloudFormation put into action. So here you put the templates inside the CloudFormation console, and then instead of creating the EC2 instances directly, you just prepare the OpsWorks stack and layers. And then the automatically created automatic OpsWorks will help you prepare the instances. So you have something like this after. And then you can have multiple websites using the same standard automated environment. And there you go, the end. So it's just, so in summary, you have CloudFormation automating the creation of the AWS resources, and then OpsWorks is there to help you automate and configure the application side. So thank you very much, and hope you discover something today.
All right. So, some questions. Let's have around 5 minutes for questions. Actually, I have a question. I think you mentioned about Lambda and NAT gateway. So, it's something interesting. I'm not sure how it works exactly, but what does it do?
Okay, so in Amazon, when you have a VPC, virtual private cloud, you have a private and a public subnet. Usually, you create a NAT instance, EC2 instance in the public subnet.
Okay.
Okay, but the EC2 instance might go down. So if it goes down, everything in your private subnet can communicate to the internet. So the NAT gateway is just a substitute for the NAT instance, where the NAT gateway will never go down because it's provided by Amazon. So it's similar to an elastic load balancer. So elastic load balancer never goes down. So for example, when you have an Nginx load balancer serving, but your load balancer goes down, nobody can access your website. So the same for NAT gateway. Amazon provided NAT gateway, so that part won't go down. So how does AWS Lambda go in? So CloudFormation needs to be updated by the Amazon Web Services team to support the NAT gateway. Since NAT gateway is something new, I'm not sure if it got released November or December, but CloudFormation has not yet been updated to support NAT gateway. But since the AWS SDK has been updated with the creation of the NAT gateway, what I did is I just made CloudFormation to create the Lambda function via a template, and then the Lambda function will execute the creation of NAT gateway. And then when that is done, it goes back to CloudFormation, and it continues the creation of the other resources.
All right.
Okay, so does that answer your question? Yeah, really nice
That's
question.
good. Anything else? Okay, there you go.
I have a question about the pricing scheme for AWS. So, when you start with CloudFormation and OpsWorks, does it start charging you, or does it start charging you for every instance you make?
So it's free. So CloudFormation and OpsWorks are free services in the sense that when you use those services, there's no additional charge for using those services if you're inside Amazon. So when you launch an EC2 instance via CloudFormation or via OpsWorks, that's when you start to pay for the resources used inside. So there's something called, so there's in OpsWorks, you'll see there in the billing page, where it says there that it's free for everything inside Amazon. But if you have to install the OpsWorks agent outside Amazon, that's when you get billed. All right, so I was also surprised that it's free. So the thing that you need to take note of is the amount of time you need to spend on learning Chef, so you can maximize the usage of OpsWorks. So if you use Chef or you have used Puppet or Ansible, and you want to write the custom recipes in Ruby, you probably need to check some blog posts or get some books, and then you can customize almost everything in the application side. But for CloudFormation and OpsWorks, it's free. Yeah, but the resources created, of course, is the same.
Right. Yeah. All right. Anything else? Okay, so we have one more presentation. Our friend Edge from Paymaya will give a short presentation about Voyager and Paymaya. But while Edge is setting up, okay, we're going to have a 5 to 10 minute open discussion. So if you have a question, feel free to just say it, and anyone can give an answer. So it's not just for the organizers or the speakers. It's more of an open discussion. So if you have something like a question burning in your mind that you want to ask, or you don't know how to approach a problem, I guess this is the best time to say it. Because I think some people like want to hear about it. I think some people talked to me earlier about Redshift, so I think it's something interesting. People have experience about that. I think I want to hear your thoughts about that. Yeah, go.
Can you share more about how Lambda works? I've used EC2, but Lambda, so it's just instead of using a server, you're just using computation power. An isolated piece of code. So how do I use it?
So, for example, the thing that makes people wonder usually is how does it work, right? So, what Lambda is like a platform where you write code, and you can either write code in one file there, or you can upload a zip file. And what it does is it executes the code when it is triggered. So the trigger points are the possible ways to trigger that is one, by a CloudFormation. You can use the notification service. You can use a combination of API gateway. So you have a website endpoint there, and then it triggers the Lambda function, and then it does something inside. So it's like a place where you write code. So it's just a normal Node.js or Python code. So you just use AWS SDK or something else.
Does it have a URL or something?
Yeah, it has.
To access it?
You to access it by URL. I think one of the, from how I'm familiar with, is you use an API gateway. Yeah, the API gateway is like a layer where it has API endpoints, and then it just triggers something below that layer. So something below that layer is the Lambda function. So it's possible to do something via that HTTP endpoint. Yeah, but you can have other ways. You have other ways to trigger that function, and the difference only is the billing part, because most of the time it's off. So for example, you don't have any traffic, you don't pay for anything, and then it scales properly. Yeah. So, but it's just a Python block or a Node.js block, and just use JavaScript or Python to code inside it. But the hardest thing to learn, the hardest part there to learn is making it work the first time. Then it will usually make you spend around 10 minutes to get that to work, because there are examples there. And then, for example, there's image magic there, and you can just use that to create your script. But it's technically just JavaScript and Python, and the only difference there is the billing part.
I think one of the examples in the West Lambda is image processing. So let's say you have for example, a PHP application. You try to upload an image, and what usually what you do is you create thumbnails out of that image. So what will happen is that normally your PHP application does it for you. So your application, instead of like spending the CPU resources for your application, it's doing image processing. Something it's not really like a part of your core business, right? So Lambda, what it does is you take out that process into AWS Lambda. So instead of uploading the image to your PHP application, for example, and storing the thumbnails into S3, what you can do is to actually upload the image directly to S3 and have Lambda recognize that as an event, and have AWS Lambda process the thumbnail for you. So it takes out the processing part out of your application, and I think you're going to save money, especially if you're processing a lot of images. So I think it's one of the really good use cases for Lambda.
Yeah. And this one is the example of a simple Lambda JS code.
Right.
So if you can see, this is just JavaScript code with a callback. So if you have used JavaScript before, this is just a function here. And where did I start? There's a handler. Yeah, okay. So there's just a handler in AWS Lambda, and you receive an event, and that event has parameters. And then after you receive the event, you just do something with the parameters. For example, here you create a NAT gateway, and you return that, hey, create a NAT gateway callback handler started general. But you can technically do anything inside. For example, here, I just make use of the AWS SDK for Node.js. And you create a NAT gateway here. You can also create elastic IP address, etc. But for this scenario, it's just a JavaScript file.
First part that talks to
The part that talks to Lambda is inside this part. So here, the one that triggers Lambda is the CloudFormation event. So it's not HTTP endpoint. But the one that triggers it is CloudFormation. So CloudFormation creates Lambda, and then it creates the function. It pulls the code inside a zip file inside S3. So we first upload the file inside S3. And then we create the Lambda function. And by the Lambda function from the S3 endpoint, then it just gets triggered. Then you create an active gateway from there. So this one is our save blueprint, that the one that we created to standardize application.
Any questions? Anyone can answer, okay, so feel free.
Well, just to add to that particular use case, yung traditional concept kasi of a service is you have one machine that has an API on it. If you don't use it, it's still there, it's still running with the OS or everything. It's waiting for you to provide something for processing. The concept of Lambda is that if you're not using it, it technically does not exist.
Yeah. Main gap in knowledge about Lambda is how do you use it, how do you invoke those functions? So it's through events or you get an API.
It's actually being integrated into most of AWS components already. Like for example, you can use it seamlessly with SNS and SQS.
Yeah.
So if, for example, you want to process very quickly text messages, you don't want to spend a lot of time on it. So it goes through your pipe. Once it's there, it triggers an event, your Lambda function kicks in, does processing to your SMS or your message, and then after that, basically dies.
Yeah.
Your message goes into another part of your workflow.
Yeah.
So para siyang mga minions lang na pack pag may dumating.
Then we trigger, yeah.
Trigger, do something.
So
It's actually cheap because you are paying for the processing time, and that the whole time an EC2 instance is active. Right?
Siya pag yata laging nako-call yung function niya, naka-cache siya.
Yeah, especially if it's really something that's repetitive, as you mentioned, something that creates your thumbnails or your size images repeatedly, so you might as well do the. And the last time I checked, it supports 2.7. I'm not sure when they are going to support 3, or is it already supported?
3 in Python?
Yes. The last time I checked, it's just supporting 2.7 or Python.
I usually use Python 2.7 for most of the time because of stability concerns. But I think 3.
But the last time I asked somebody from AWS Singapore, they said they're going to roll out support for 3 as well.
Okay, so nice discussion. Okay, so I guess let's have the presentation before we go.
Just very quick lang. I'd like the bonus content for today. Kasi you have 2 topics, so you get one. So
parang more.
Yeah, it's very sulit na yung pagdating nyo dito. Yeah, so very quickly lang. So you're for those of you wondering, so you're here at Voyager's office. So what is Voyager? I'm sorry. By the way, that's me. My name is Edge Dalmasio. I'm actually from Paymaya, so I'll be talking to you about 2 companies, Voyager and Paymaya. That's my cat, Buster. So the internet says na cats are like everyone's favorite. So, yay. And so, quick question lang. So some of you have probably heard this term, software is changing the world. So there's some companies here. Do you know what the valuation of the companies are on this slide? It's like how much they're worth.
With Google Maps separately.
Sorry?
The valuation of Google Maps.
Yeah, valuation. Actually, I don't have it here on my notes. But Airbnb, worth 25 billion.
Netflix. We have Netflix here in the Philippines. Yay! So it's worth 30 billion. Uber is about worth $60 billion. So WhatsApp is bought by Facebook for $22 billion then. So if you think about it, these are just software companies that are worth billions and billions of dollars. So see Voyager, it's actually a spin-off from the PLDT group. Who's heard of the company PLDT? So, yeah. Some people hate them. It's understandable, but it's pretty much a big business. They have money, so they figured out. Guys, we need a slice of this internet of and whatever it is, spy. So that's pretty much what Voyager is. It's an independent business unit away from the PLDT that some of you love or some of you hate. So if you think about it, so there are different pillars in the PLDT group. So you have individual, it's smart and sun, it's home, PLDT, DSL. There's enterprise. Some of you probably heard of SME Nation. You have multimedia. So I'm not really sure who those guys. Multimedia TV5. Yeah, TV5. And this is where we are. This is column na to. So we have our own space, the digital space. So leading the digital space is yung Voyager Innovations. This office, actually the office then right below this one. That's also a Voyager. I'm from, who's heard of the Paymaya? Who's from Paymaya? Okay, who's from Voyager? So, yay, home court, konti na tayo. So, so that's where we are. So what we do, so pretty much we do cool things that matter. So we notice that there are a lot of software companies na parang, it's cool, di ba? Pero parang how do you monetize that? It's hard. So parang the owners, they kind of just spend and spend and spend, but they don't really know how to monetize. So for Voyager, it's not only about building something cool, it's about building something that matters. So when you open your Uber app, Uber knows that every time you open your app, or almost every time, you're going to spend money because you want to go somewhere. Right? So for Airbnb, pretty much the same thing. So you use Airbnb, you want to go somewhere, you spend money on it. So those are things that you monetize. Kumbaga, it's nice to have something cool, pero if you can't monetize that, you can't pay the engineers. So, magutom yung families nila. Too bad. So, we don't have a mic here, so let me just see if I can play this one. So, Talk2 is one of the Voyager's apps. It's not very popular here in the Philippines. Let me see.
Many Filipino families
Right.
live far from each other and encounter a number of problems when they try to connect with one another. Right now, Filipinos abroad can call their loved ones back home with their smartphones, but cannot reach them anymore when they aren't online. Calling abroad costs too much, making it expensive for families and friends to connect. Why keep missing the moments you need with each other when you can be called and texted as if you're at home? Introducing Talk2, the free mobile app that gives you your own unique and permanent Philippine number. Not only can you call and text the Philippines at the most affordable rates, but also receive calls and texts for free. Enjoy endless texting to the Philippines anytime. There's no need for you to have a second phone or a Philippine SIM with roaming. Just download the app for free. Never miss another moment to talk to each other. Download Talk2 now.
Yeah, so some of you probably not heard of Talk2 here in the Philippines because it's more popular with OFWs. So if you have an OFW relative, someone's messaging me, ask them to download Talk2. You can talk to them. They're here in the Philippines, so it's very close to home. So those are one of the things that Voyager does. Everyone's over 18 naman dito, no? So I'm guessing. So here's another thing that Voyager did. I'm not going to tell you what kind of website it is. I'm going to ask you after. guess. What kind of website is takatak.com? But hindi align. No? It's an e-commerce website. It's pretty much like Amazon. So you can go to Takatak. We have different merchants there. You can buy GoPros, bra, so makeup. So you can buy all sorts of things. So Voyager helps the merchants try to sell their product via Takatak Concierge. So they take the pictures, they make it pretty. So when someone goes to Takatak's website, it's easier to sell their wares. Because the merchants, they really just want to focus on selling their product. It's not their expertise to advertise. So that's one of the things that Takatak does. It's not only a website, it's a service to the merchants. Pretty cool stuff. So some of the other stuff that Voyager is working on. So we have about 100-something engineers. So these are doing products. So it's quite a lot. Safe Zone gives free internet. For example, if you access, if you're a Safe Zone member, you access BPI's website, you don't have to pay for data. Smart Padilla, it's the largest, I think, domestic remittance if you want to send money to the province. Takatak's there. So it's a lot. So yeah, okay. So why ako naman, I'm from a company called Paymaya. So si Paymaya, if you've not heard of Paymaya before, this is what saan na yung clicking ko? Yes.
Sure, you can buy anything online nowadays, but we know that getting a credit card is such a hassle. Good thing I discovered Paymaya, my very own virtual Visa. Download, load up, shop. With Paymaya, I get access to endless deals, items, and rewards. It's just like having a credit card, but without the hassle. Now I can do all this without a credit card. And now you can with Paymaya.
Sino may credit card? Diba? Yeah, may credit card. Sino walang credit card? Sino gusto magka-credit card? Not a lot of people. Right? One of the markets that Paymaya is trying to address is a lot of people in the country don't have a credit card. Why is it important to have a credit card? So if you want to take a flight, for example, Philippine Airlines, Cebu Pacific, usually you get the discounts online. So if you don't have a credit card, you don't get access to that. If you want to play games on Steam, if you don't have a credit card, you can't pay cash. There's no ATM deposit on your machines as you can. Parang you throw money on your screen, nothing happens. So you can download Paymaya. You can go to nearby 7-Eleven. You can load it up and then you can start playing games on Steam. It's pretty cool. So if you have iTunes, Play Store, you can use it there. Some people also don't like to apply for a credit card because technically utang siya. Every time you use it, umutang ka sa bank. So it's not. Hindi kami nagpapautang sa inyo. You put money in so that you can use it. So it's up to you para i-budget siya. It's like a prepaid credit card. For very quickly lang, so Paymaya, the company, not the product, it's a reboot of Smart Money. So Smart Money actually, weird because it's a Silicon Valley. Parang people are like mobile money na. Pero it actually all started here in the Philippines back in 2001 when Smart Money came out. So it's not really as popular as Smart wanted it to be. Pero we're trying to give a spin to that with Paymaya. As part of Paymaya, we also power yung Smart Padilla na program. It's the largest, sabi ko na before, remittance program in the Philippines. We also issue Visa cards and MasterCards. We can also accept payments, so Visa and MasterCard cards. So who's sort of the company called PayPal? Wala. Oh, oh no. How about Stripe? Stripe. So yung so PayPal and Stripe, we're trying to do that here in the Philippines. So parang why don't I just use PayPal if you're asking? But kasi it's they have higher rates. We can give you better rates saka more personalized fee because we're here in the Philippines. Pwede mo kaming handlingin. So say PayPal, you have to go to the States and parang venture up. So another very nice thing about Paymaya is, so you probably heard of PLDT, like kanina. Who's heard of Rocket Internet? Rocket Internet. So they're not very popular as Rocket Internet, pero not a lot of people know that the main brands like Zalora. Who knows Zalora? Zalora. Yes. Lazada. Lazada. Easy Taxi. Hindi siya ganun ka-popular. Yeah. So QuickBus. So these companies are actually Rocket Internet startups. So Rocket Internet is a company that copies other business models that work. So si Uber. So Uber works. So parang let's put Uber in a different country, pero let's give it a different name. So Amazon works in the US. Let's take it to a different country and give it a different name. So you have Zalora and Lazada. So those are, pero right now Zalora and Lazada and Takataka are pretty much at the top of the local e-commerce space. So that's Rocket Internet. So yeah, so Paymaya is actually a joint venture between PLDT and Rocket Internet. And there's really a lot of growth in terms because Rocket Internet allows us to have access to all the other Rocket Internet companies across the planet. So pretty cool stuff, right? So by the way, why am I here? Because we're trying to look for good people to join the yes.
That's why we have free food.
So normally, if you have access to free content, there's advertising. So pretty much, we've had a big town hall yesterday. It's like parang level siya ng Bulaga, and like we have satellite. Parang may mga 16th floor, 9th floor, everything. They're trying to who's Manny Pangilinan, the head of PLDT. Di ba nga I said he's trying to have a space dun sa internet world na yun. And he's pretty much trying to build his own Silicon Valley here in the Philippines. So that doesn't only mean the money, it's also about yung culture that we're trying to build. So we're using AWS, we're partnered with a big internet company. So outer space. Huh? Outer space. Why outer space? We send them to nice events. So to meet beautiful people, and so this is me last year, and pretty much my boss. And so when you go out, you come back, you try to teach people what you learn. So that's one of the things that we try to encourage. I'm going to skip this slide, and thank you so much. Alright,
So I guess that concludes our meetup for tonight.